Well, when we can say we easily can deploy and scale and update containers and keep them alive and automatically fix them if they break, we use something called Kubernetes. Now, there are other things. HashiCorp has its product set. VMware can do many of these things around virtual machines. But Kubernetes was written by Google and friends. It has become kind of the basis for deploying in an automated fashion containers. So let's look at what the heck this really is, right? It automates the deployment of containers into something called pods. Pods are groups of containers. So if you're just launching a single container, it's a pod of one container. But let's say that container needs a logging server to go along with it. Those would be grouped together and thought of as a single deployment unit, so pods. Pods are generally affinity, anti-infinity. They tend to run across different places. So if a machine dies, you have pods that are still up and running. Pods can be grouped together from a load balancer, so you can reach 3 of them from a single network call, and it just round robins to them, those types of things. They have all these features, affinity, anti-infinity. Affinity just means 2 things that need to run together on the same server, or affinity would be these machines, maybe their database host, need to run close to the data, so make sure that those run on the same machine. Anti-affinity says if I've got 2 pods, I certainly don't want to load them both on the same machine if I've got other machines available. Auto-scaling, we know, scale up, scale down. Volume management for storage, you can attach those. Load balancing, layer 3-4 networking, service discovery, which is pretty much building out DNS capabilities, making sure things are running, making sure things are performant, and rolling updates. All of these things are built into the Kubernetes platform, right? And it works again on this desired intent. So you actually state your intent, and Kubernetes automatically tries to see if anything's different than your desired intent and adjust the system to meet that. Okay? So again, as we look at some of the features, it has an automatic intelligent scheduler built in, so it's going to make sure it follows all the rules for affinity, anti-infinity, data locality, those types of things. It also watches to make sure if you request that 3 versions are running, it keeps 3 versions running. If one machine dies, it simply creates another version so that you have 3 running. If you want it to scale, you just tell it how you want it to scale, it'll scale. It orchestrates the storage layer from you. It actually produces a namespace version. So you say, I need 10 gigs of block, and it provides underneath where the closest and most performant 10 gigs of block are, and it connects them together. Why this is important is it doesn't necessarily even have to be on the same machine if it's performance enough for your requirements. But if your machine fails, it spins up another machine and reconnects it to that storage if it's available, and it can do that automatically simply based on the namespace. It does load balancing, service discovery, automated rollouts and rollbacks. We'll take a look at that here in a minute. It can keep track of your passwords for you. It doesn't put them in the software itself. It can control all your secrets. It can control your certificates, those types of things. And you can actually do things like set things off with a cron job so that end of month it'll spin up a bunch of additional storage that crunches your month-end numbers and then automatically deletes them as those resources are no longer deleted. So again, we talked about a little bit about some of the concepts of pods. Volumes are simply storage, whether it's block, object, NFS, however you need that to be. Labels are very important in that you can label just about anything, and then you can connect things or call things via labels. You can provide updates via labels. So that's a really powerful concept in that you're not naming a machine. Any machine that gets created can inherit this label. So we'll take a look at some of the things you can do with labels. Again, I talked about some of the security keys. It does a great job of making sure that the security keys are properly taken care of. Replica sets are simply, if you need any number of replicas maintained, it does a good job of keeping those maintained. Stateful sets guarantees about who comes up first and who goes down. If you need any of that, you simply declare it in your manifest. Services are a good way to create a sort of a DNS entry to call a replica set of containers. Great way to load balance things, and it's done with a very simple component of the architecture, and we talked about batch jobs already. So what does this architecture kind of look like? This is one of the really interesting things in that when you're working in Kubernetes, you have a master node, and that master node actually has 3 copies of a database. Those 3 copies store the desired state. And that desired state, the front end for that desired state, is called the API server. It handles updating the database, and it handles anybody's calls in and out. It's actually just a RESTful web server almost that you use to receive calls and distribute the information back out. So it's really just a front end for that database of the desired state. You have a couple of other things. You have the controller manager that manages replication, namespace, sets up service accounts, those types of things, and the scheduler. And the scheduler's job is simply to load balance amongst the worker nodes where you run individual things. So if one worker node becomes overloaded, the scheduler may actually remove a pod from that one and move it over to another worker node simply to balance out the amount of use of the CPU, memory, and storage. Then on the worker nodes, those are separate machines, and they run a process called kubelet. And kubelet looks at the state that is in the API server, looks at the state that it has on the local machine, and makes any changes on the local machine to make sure that it keeps the state as close to the desired state as possible. So in this sort of method, all of the actions, all of the intent, the command line things are done by kubelet based on the changes that you make on the API server. So the API server is my desired view of the world, whereas kubelet is the automated worker node trying to make the world look like my desired state. So if the scheduler adds a new container, a new pod out on your worker node, the worker node checks in, says, oh, there's a different version of my my desired state, and the difference is I should run this pod. So it calls Docker, and it actually starts the containers in that pod and manages that pod as needed. So it's a distributed system. There are systems out there with 20,000 worker nodes on a three master node cluster, and it works just fine. It's infinitely scalable because your API server is really just a text file. It just is a web server, if you will, with a back end of the database there. So it's the way you get somebody like Google to scale out their entire infrastructure using this type of system. So let's take a look at Kubernetes, and let's take a look at how the dashboard works. So let's take a look at the Kubernetes dashboard. This runs on the generally on the server node, the master node, and it allows you visually to access your server. Now later we'll be doing a lot of this via the command line to show how easy some of this stuff is, but I just wanted to show you a little bit about what's included in the server. So what we've done is we've created a deployment called our first deployment. It's got a pod in it. It's running in our small minikube here, and we have one replica set of one pod. So if we wanted to further take a look at this, we could see that we have given it an IP with a node port of 3096, and we could actually address it by that. We also can see our Kubernetes service running, and we have our default token, our secret password here. So those are the things you can look at. There are other namespaces, and if you want to change those namespaces, you could go look at, say, the Kubernetes system itself. Here you see the DNS and the actual dashboard service running, as well as a storage provider providing storage to the cubes. But we're going to go back and actually look at the default namespace. So within this, you can go into your cluster, you can see your namespaces, but we can go in and look at our actual nodes. Here's our Minikube node. We can see what our CPU and memory access is on that node. For that node itself, we can actually go in and look at the allocated resources. So when you have a group of workers and you want to see how you're doing and how you're building up allocated resources, you know, is it time to upgrade, maybe add another worker node? You'll be able to see that in here that we've allocated so much percentage of our CPU cores and memory and pods themselves. You can also see whether or not we've got any of our conditional flags set. So you can actually modify your cluster based on these conditional flags. So if you're running out of disk or you have memory or disk pressure, you can actually go in there and say, if that flag turns to status true, then I can do something additional. I could add more storage, provide, you know, create another storage provision, those types of things. The way to do that is to go look at your persistent volumes. I don't have any on this Minikube. I'm only offering local ephemeral storage. But let's say I had a NAS system or something. I could see it here. I could see how much was allocated. I could allocate more to it. In the roles tab, we don't have any roles set up. We don't actually have any storage classes set up other than our standard ephemeral storage here. But you can also work with those in the cluster. So those are things you can do. You can also look down here in your workload and see what various things you have set. So I could address any of those. I could address my load balancers, and I could also look at my configs and storage settings. And visually see these. So again, if you want to look through any of the actual logs, the events are right here as well. In addition, if you want to look at, let's look down here at our services. I can look at this deployment service. I can see that it's been up and running and has a replica set. One of the nice things about it is you can actually pull up the YAML file. It will actually create this on the fly straight out of your API server. I could actually edit this and then click on the update and apply those changes here. So I can actually do any of the config changes right here from this as well. I'm not going to do that. I'm going to go ahead and cancel out of that. But it gives you a nice graphical way of actually looking at the status of your pods. Again, later on, we're going to do this, most of what I just did with the command line to sort of understand the API-driven infrastructure. But all of this is just a visual. When I click on something, it's just issuing a RESTful API command out anyway. So I'm just doing it from a web page here. But this is included. It's easy to launch and pop this up and graphically start to learn how to do the Kubernetes from a nice graphical interface. Okay, so now that we've looked at how the dashboard works that ships with Kubernetes, let's see a little bit more about how it works under the cover. So under the cover, I said that this API server, as you see up in the upper right corner here, it's just giving out web pages or API pages. So it's a get. It's a RESTful API with get and put commands, if you will. And so what we see on the left here is we're actually going to go in and look at the API server, and I'm going to ask for a node list. And it's simply going to put out, this is actually in JSON, which is what it uses in its version here. And it's just putting out the information about what's on that node. So the kubelet over on the worker node would check in. You see the resource version over here. If it's got the same resource version it had last time, it's not going to do anything but go to sleep and check again in a little bit. If that's changed, it's going to read down and see what's changed, right? It knows that that it's got to run specific things based on its I think it's over here, it needs to run this test container on the left here. And it reads that, and it may have to launch the test container. So it understands its state of the world from this API server just by simply saying, get /API/v1/nodes, make sure it's, I read down to my section of the nodes, and I launch everything that it says I'm supposed to launch on there. And you actually change that API server by applying a little text file called a YAML file, and we'll look at those here in a minute. And that changes the status of the API server. It changes the resource version number. The kubelet checks in next time, notices the resource version number has changed, and tries to make the world look like this API server has its vision of the world.